So for number 4, an object oscillates along a vertical line, okay, and its position in centimeters is given by y of t equals 30 times psi of t minus 1, where t is greater than or equal to 0. Just in general, the t or the time always non-negative, and it measures in seconds. Y is positive in the upward position or upward direction. It goes up positive and then come down negative. Part A, graph the function or graph the position function y of t equals 30 times psi t minus 1, where t between 0 and 10. Okay, it might be more convenient to do it with a graphing calculator. And if you have to do it by hand or no graphing calculator available, and you just think about y equals 30 times psi of t minus 1, and then if you expand them or multiply 30 to the terms, you might get, you're going to get y equals 30 times psi t minus 30. And think about this is the function psi, and the nature of the graph start at 0 and go up and down, up and down, up and down. The 30 is the amplitude, okay, the amplitude. And negative 30 is the vertical shift, or it go up or down in the y direction. This one is negative 30, gonna be negative, like going down, down to the bottom. With the amplitude 30, that means the maximum of the basic graph gonna be 30, minimum gonna be negative 30. With the adjustment or with the vertical shift negative 30, the graph, if if this is 30, this is negative 30, and this is negative 60, original graph is supposed to be something like this, okay, something like this. And the period is 2 pi. For our case, it has negative 30, so that means the position here, original at 0, 0, is going to go down 30 units. The maximum 30 going to be down to 0, and the 0 go down to negative 30. That means you move the graph downwards by 30 units, and the graph will look something like this. And this is at, come back to 30, negative 30. Okay, so this is a sketch of the graph. To get the perfect one, just put in a graphing calculator. But we need the t from 0 to 10. 10 is a little bit greater than 3 pi. Okay, as pi equals like approximately 3.14 something. So if we keep going, so half of the graph is at pi, the full graph is 2 pi, another half of the graph. So gonna go up a little bit and then go over right here if this is the 3 pi. So that one is 3 pi and a little bit down further. So that pretty much the sketch of the graph from 0 to 10 seconds, or t in second here. Okay, that's a graph of the position function. So y at t. And part B, find the velocity of the oscillator, or the problem already provide you v equals y prime, or the velocity is the rate of change of the position, which we're gonna see more example in the next section. Okay, so velocity v, or the first derivative of the y. Since y is, we're gonna borrow the expanded form here, maybe easier to handle each one of them. So y equals 30 sine t minus 30. So the v is the derivative with respect to time t of 30 times sine of t minus 30. And then do the derivative one term at a time. For the first term, you have 30 as a constant multiple, multiplied by the sine of t, which is cosine of t. Recall the sine begins with the s, so the derivative gonna remain the same as the positive sign, and derivative of 30 or negative 30 is 0. So we have the velocity function as 30 times cosine of the t. And then in part C, graph the velocity function. Similar way that we use the concept to sketch the graph in part A, as v equals 30 times cosine t. So no additional term, that means no vertical shift. The graph doesn't go up or down, just the basic cosine graph. The basic cosine graph is like beginning when t is 0, the graph is at the maximum and then go down and up like this. Okay, the number 30 tells you about the amplitude. So the amplitude is 30. So maximum 30, minimum is negative 30. To sketch the graph of the velocity function at the time, this is going to be y prime, which is the v or the velocity. At the point 0, make some more room. So 30 here and negative 30 as the lowest point. At the beginning 30, and again the period of the cosine is 2 pi. Go up and down, up and down. So right here, halfway or half of the full period. One period takes 2 pi, and then keep going. Okay, keep going. And halfway here at 3 pi, it's gonna come back down to the bottom and then go back up a little bit to hit at the point t approximately t equals 10 right there. All right, if you compare the graph of the position function, which is the y, and the graph of its derivative, which is the v, so this is v or the y prime, similar to the way that we did, we analyze to get the graph of the derivative of the function when we were at 3.2. Let me use different color. Let's see if I can work on that without messing it up. So let's use color. Let's use different color here. So wherever the slope is 0, you see right there, right there, right there. Okay. So that means at pi over 2, at pi over 2, the slope is 0. That is the point, the m or the y prime equals 0 or the v equals 0. And the same over here, that's a slope in between pi and 2 pi. That means it's at 3 pi over 2. So right there, and also another point, slope 0. On the left side of the first 0 tangent line, the slope positive. So that means the graph is positive. Between the first 0 and the next 0, the graph is decreasing. Slope is negative. Between the second 0 tangent to the third 0 tangent, the graph is rising. So the graph rising. Okay, rising, going up, and then hit 0, and then go back down again because this is decreasing. Okay,